All right, friends, this is a bit of a long lesson, so I'm going to try to talk faster than I usually do, and even given that, you probably want to turn up the speed to at least 1.5, maybe even 1.75 to get through this thing. So here we go. All right, let's see here. I'm going to talk about prisms first. A prism is a polyhedron with two congruent faces called the bases that lie in parallel planes. The other faces, called lateral faces, and I think I used that terminology in the previous lesson, are formed by connecting the corresponding vertices of the bases. The segments connecting these vertices are called the lateral edges. So if you look at my little diagram I posted here in the notes, you can see that the bases, okay, you're only in a prism, you're only going to have two polygons that are congruent and parallel to each other. If you got a set of congruent parallel polygons, those have to be the bases. So I don't care which way that thing is sitting, the two congruent parallel ones will be the bases. The others are called the lateral faces. Okay. Each lateral edge is perpendicular to both bases in a right prism, and we are only going to deal with right prisms. I'm going to show you some oblique prisms, but really all the problems we're going to work are going to be on right prisms, so don't worry too much about that. And in order to calculate the surface area, you're going to need to know the height of the prism. So the altitude of a prism is a perpendicular segment that joins the planes of the bases. The height of the prism is the length of an altitude. Okay, in a right prism, the lateral faces are always going to be rectangles, and a lateral edge will be an altitude as long as it's a right prism. In an oblique prism, some or all the lateral faces are non-rectangular. So here you have some right prisms, and here you have some oblique prisms, and you can see that these lateral faces are parallelograms and not rectangles, and the lateral edges are not an altitude. So, I mean, you can find the height, you can find the altitude, but we're not going to busy ourselves with that right now. We're going to stick to right prisms. All right, so the sum of the areas of the lateral faces of a polyhedron is known as the lateral area, right? That makes sense. Sum of the areas of the lateral faces is the lateral area. The sum of the areas of all the faces of a polyhedron is the surface area. Sorry, my pen's not working well. You can also think of surface area as the sum of the lateral area plus the area of the two bases. So we often write it this way, lateral area plus 2, and then we use the symbol of the capital B to be the area of a base. So capital B in this case is the area of a base. All right. So now I'm going to give you another term you may or may not have heard. It's called a net. A net is a two-dimensional representation of all the faces of a polyhedron. So in other words, if you cut the prism or the polyhedron, whatever it is, along some of the seams and spread it out into a two-dimensional figure, it's going to be a net. And there was a time in honors geometry when you had to be able to identify the nets of several polyhedron. I don't know why, but that they took that out of the curriculum, so you don't have to know that anymore. But I think it would be a good idea for you to recognize the net of, say, this rectangular prism here, because it helps you kind of to understand where the formula for surface area comes from. So this is a rectangular prism, the net of a rectangular prism. Okay, and so now we're going to learn these formulas. It's good to remember the formulas, but if you really understand what you're doing, knowing the formulas isn't that hard and it isn't that necessary. So here we go. The lateral area of a right prism is the product of the perimeter of the base and the height of the prism. So here it is, LA equals perimeter times height, perimeter of the base times the height, and the surface area, just like I told you earlier, we're just going to take the lateral area and then we're going to add the area of the two bases. And they may be, they'll be a polygon of some sort. So let's take an example here. What is the surface area of the prism below? Okay, well, let's find the lateral area first. The lateral area equals the perimeter times the height, and we know this is a right prism, so we know the height is 6 centimeters. And so let's find the perimeter of the base. Oh, thankfully for us, this is a Pythagorean triple. Hopefully you haven't forgotten about those. That means this edge, not 4, this edge is 5. It's a 3, 4, 5. So the perimeter is 12. The height is 6. So I got 72 there, 72 square centimeters. And let's find the area of a base. The base is a triangle, so I'm going to have a half base times height. So we'll call 3 the base. We'll call the base of the triangle. Okay, so 3, and we'll call 4 the height of the triangle. So that's 6. So 2b then, because we got 2 bases, 2b would be 12. So our surface area is the lateral area, which is 72, plus 2b, which is 12. So that's going to give me 84 square centimeters. All right, that's how we find the lateral area and surface area of a right prism. Okay, let's talk about cylinders. Cylinders like a soup can or a tennis ball can. It's a solid with congruent circular bases that lie in parallel planes. The altitude of a cylinder is the perpendicular segment that joins the planes of the bases. And the height, of course, is the length of that altitude. Okay? And so here's how we find the lateral area and surface area of a cylinder. The lateral area is 2 pi r times h, which, hey guys, that's still the perimeter times the height, right? Because the perimeter is 2 pi r in this case. All right, so there's nothing new here, nothing new here. Perimeter times height is the lateral area. And the surface area, again, is the lateral area plus 2 bases. All right, so let's take an example here. Surface area of a cylinder. I'll try to sketch us a cylinder. Okay, so there's our cylinder. It's got a base radius of 4 and a height of 6. So I know the lateral area is the perimeter times the height. The perimeter is 2 pi r, so 2 times pi times 4, and the height is 6, so that'd be 48 pi. All right, and the area of the base is pi r squared. So let's see, r squared would be 16, so that would be 16 pi. So 2b would be 32 pi. So the surface area is lateral area plus 2b. So that's going to be 48 pi plus 32 pi. And that's going to be 80 pi. What do we got here? Square inches. Let me double check my answer. I believe that is correct. Okay. Here's another one. Why don't you pause here and try to do this one, and I'll come back and tell you what the answer is. Well, that turned out to be a bad one to leave you with. I didn't realize it was going to be quite that way. But anyway, they give us the surface area, 380 pi. So I plug that into the formula. Surface area is lateral area plus 2b. All right, and then I know the lateral area. I had to come over here. The lateral area is the perimeter, which is right here. Here's the perimeter. Okay. I'm having a lot of problems with this pen. I apologize. So there's the perimeter, 2 pi r, and the height is 10. All right, and then 2b is 2 times pi r squared. Okay, so what I did then is I factored. So if you look, I've got a 2 pi in this term, a 2 pi in this term. So I factored those out, and then that left me with the 10 plus the r. Okay, and then I simplified both sides by dividing both sides by 2 pi. That's where this came from. All right, and that left me this equation right here. Okay, and since it's quadratic, what I wanted to try to do is to factor it. So I got everything on one side, set it equal to 0, and sadly that does not factor, and that's when I realized I had to use the quadratic formula. And here's the quadratic formula in case you don't remember it. And then when you plug all that in, this should be 4AC. All right, and when you plug all that in and do the number crunching, I got about 9.66 centimeters for that radius. Okay, great problem. You're welcome. All right, a cylinder such that the segment joining the centers of the bases is perpendicular to the bases. Joining the centers is perpendicular, it's a right cylinder. And that's all we're going to be dealing with. So don't worry about oblique cylinders unless otherwise specified. Okay, so if it's not specified, assume it's a right cylinder, a right prism, a right everything. Okay, let's move on to pyramids. pyramid is a polyhedron in which the base is any regular polygon and the lateral faces are all triangles. With a common vertex. So you can see that top vertex there where all the faces come together. All right, so the altitude of the pyramid is the perpendicular distance between the base and the vertex. And by the base, I'm talking about the center of the base, which, as you remember from polygons, that would be also the center of the circle that is circumscribed about the base. Okay, the center of the polygon. All right, what do we got now? We got a regular pyramid. This might be called a square pyramid too. I'm not really sure. I think I may have failed to mention when I was talking about prisms is that the way you name them are by the shapes of their bases. So for instance, you could have a rectangular prism. A square prism would be, I'm thinking cube. I guess you could have a square prism whose lateral faces were rectangles. You could have a, hexagonal prism, a pentagonal prism. And so the same goes here for pyramids. Whatever type of base it has, that's what you're going to call it. And I do believe this should be square and not regular. So let me put that there. All right. And what we need to know about a pyramid is its slant height if we're going to find its area. Okay, and what is the slant height? The slant height is the length of the altitude of a lateral face. Okay, and remember, the lateral faces are all triangles. The height of a triangle is the perpendicular distance from the vertex to the base. And then when I tilt those triangles over to make a pyramid, you can see that the slant height is really just the height of any one of those triangles that makes a lateral face. All right, and down below here is the net of a pyramid, and hopefully it helps you to understand how to find the lateral area and surface area. Okay, so I can see that I'm really going to have to find the area of a base, and then I'm going to have to find the area of every one of those triangles. Well, how am I going to do that? I know the area of one triangle is a half times the slant height times the base, right? A half base times height. So the lateral area is going to be a half times the perimeter of the base times the slant height, which we call with a cursive L. So slant height is cursive L, which is really just the height of the triangle, so there's nothing magical there. Okay, so that's how we find the lateral area. And then, because we've only got one base in a pyramid, we're just going to have to find the area of one base to find the surface area and add that to the lateral area. Okay, so let's do it here. What is the surface area of the hexagonal pyramid? Okay, first we need the perimeter. Well, let's get the lateral area. It's a half times the perimeter times the slant height. So 1/2 the perimeter. Let's see, the sides are 6 inches. So 6 times 6 going to be 36. The slant height, they're giving it to me there, is 9. So when I crunch all that out, I get 162, and I'll put the units on in a minute. Okay, now I need the area of the base. The area of the base Okay, it's a regular hexagon, so remember it's got 6 equilateral triangles. So I'm going to use this favorite formula for finding the area of a regular hexagon. So I can find the area of one of the triangles, multiply it by 6. So that's going to be 3 times the square root of 3, and s squared is going to be 36, 6 squared. All right, and then so that's where the 3 came from. That's where the 2 came from. So there's the area of one base. So let's simplify this a little bit. So surface area is lateral area plus the area of the base. The lateral area is 162. The area of the base is, let's see, that'll be 18. So 54 times the square root of 3. And remember, I cannot add these two things together because I would need a radical on this number too. I'd need the square root of 3 if I could add those. So that's as simplified as you can get. I don't want you to turn it into a decimal in case you're just dying to know about what it is. And I'm still trying to get my pen to work so I can put the inches squared on there. Okay, so now we've learned how to find the surface area of quite a lot of things. What we got to do next is a cone. So if you need to take a break here, I'm sorry. I know this is long. This is one of the longest ones of the year. So take a break if you need to. Come back. I'm actually going to take a break and go put a new battery in my pen and see if it works better. All right, a cone. A cone is a solid that has a circular base and a vertex that's not in the same plane as the base. Everybody knows what a cone looks like, right? You've had an ice cream cone. The altitude or height is the perpendicular distance. Well, I guess it wasn't the battery because my pen is still messing up. Perpendicular distance between the vertex and the base. The slant height is the distance from the vertex to any point on the edge of the base. So vertex to any point on the edge of the base is the slant height. Anywhere along here, slant height. Okay, so part of a cone that consists of all segments that connect the vertex with the points on the base edge is called the lateral area. So everything except the circle that is the base is the lateral area of the cone. And how are we going to find that? Probably I'll have to remember this little formula here. Okay, the lateral area of a right cone is half the product of the circumference of the base and the slant height of the cone. So it's very similar to the pyramid, right? Okay, sorry about that. So the lateral area of the cone, half the product of the circumference times the slant height. So what you got, half times the circumference, which is 2 pi r, times the slant height. Well, that goes away. So what you got is pi r L for the lateral area. And of course, for the surface area, you're going to have the lateral area plus the area of the base, which is going to be pi r squared. All right, so let's do an example here. Find the surface area of the cone. Well, we got to find the lateral area. Lateral area plus the base. The lateral area is pi r L. Okay. All right, so let's see, the radius here is 15. Slant height is 25 times pi plus pi r squared. Let's see, 15 squared is 225. All right, so 15 times 25, 375 pi plus 225 pi. So 375, 225, I think that's 600 pi. And what do we got? Centimeters? Square centimeters. All right, surface area cone, pi RL plus pi r squared. Got to remember that. Okay, now we got a sphere. I think this is our last figure. Yeah, guys, we're in the home stretch. Sorry about the length. A sphere. Sphere is a set of points in space that are a given distance from a point called the center of the sphere. So the center of the sphere is equidistant from any other point on the sphere. All right. A segment from the center to a point on the sphere is, as you might assume, a radius of the sphere, and a segment that passes through the center of the sphere with endpoints on the sphere is a diameter. And it is twice as long as the radius, just like it would be in a circle. All right, and we have this thing. I apologize for all the interruptions. This is my dog. The intersection of a sphere and a plane that contains the center of the sphere is called a great circle. So you remember a little while ago we talked about cross sections. So if you take a cross section of the sphere that contains the center of it, you're going to have a circle, and that's going to be called a great circle. Not a good circle, but a great circle, by golly. All right, and then if we got half a sphere, then we know that's a hemisphere. Do you know what hemisphere you live in? I hope so. Separates the sphere into two congruent halves. And here's how we find the surface area of the sphere. Okay, needless to say, there's no lateral area because there are no bases of the sphere. The whole thing is the surface, no bases. So we just have one formula for surface area, and it is 4 pi r squared. So as you can imagine, it's really quite simple to find the surface area of a sphere. 4 pi r squared. So this sphere has a diameter of 10, so that means its radius, oh my gosh, that means its radius is 5. So 4 times pi times 25. So that's going to be 100 pi square meters. All right. And that's pretty much it. So we had prisms, we had cylinders, we had pyramids, cones, spheres. A lot of work there that we jammed into one lesson. So sorry about that. All the rest of these problems are for you to practice. I've taught you every bit of this, so all I'm going to do now to save us from having any more time in this video is to tell you to pause it. I'm going to write the answers up, and you're going to come back and check your answers, and then you'll be finished, and the next lesson will be on volume. Alrighty, the first one here, the only thing that made it difficult was because we didn't know the slant height. We didn't have this figure, so we had to use Pythagorean theorem to figure that out, and I really just put all this in. I mean, the numbers were so big, I just went ahead and put it all into my calculator. Hope you did too. Got that for my surface area. Next one is a hexagonal pyramid. So just plug the numbers into the formula. Here's how I used our trick, our favorite trick for finding the area of the base. And this is what the final answer is. Surface area of a cone, just plug the numbers into the formula again, 96 pi square feet. Surface area of a sphere, plug numbers into a formula, got 144 pi square centimeters. Then we have a triangular prism. How do I know the triangles are the bases? Because remember, there are two parallel bases in every prism, and that's what the parallel polygons are, the triangles. So plugged into the formula. Here is my, let's see. Oh, I knew the triangles were equilateral, so I used that formula again and got this for my answer. And then finally, I had a cylinder, and I know I got to add the lateral area to base areas, and I came up with 72 pi square meters. I really, really hope you did all those problems to get the practice. Do the homework. If you have any questions, always happy to answer.